I want to show you what can be done when you see that some of the p-values are not good. So one of the things that I haven't explained about the validity of the multiple regression is that if there is a collinearity between the variables, the multiple regression has a big error and it's not advised to be used. So see, the overall significance is very good. Okay, it's highly significant, 3 times 10 to the negative 19th power. However, you have a few coefficients that are not so significant, which kind of makes you wonder that maybe we shouldn't be using all of these. So what might be happening is the following. Maybe this third variable width can also be predicted from length and height. Makes sense, right? If you catch a breamfish that's long and height is big, probably its width is big as well. Don't you think? Right? So it's reasonable to think that there's some kind of a linear relationship between these three variables, and in such a case we say the variables are collinear. In those cases, you should drop some of the variables. And you can see that even if you drop some of the variables, the significance doesn't drop, or even it might improve, and the p-value will also improve. So let's try that. So where was my data? So here's the data, and what I'm going to do is I'm going to go to the data, do the data analysis, and then go to the regression. Okay, and then we'll choose the y to be the weight part. And then for the x range, last time I included all three, length, height, and width, but this time I'm only going to include length and height. So this is what we want. And then the very first line is the label, so you should click on the label. Let's try to run it. Let's see what we get. Okay, what did we get? Right. Let's make it bigger. Okay, so what happened to significance level? It improved. It's 10 to the negative 20th, right? It got better. And the p-value improved by a lot as well, right? The height had like, before it was like 4 times 10 to the negative 4th power, and now it's 10 times smaller. And even the length, which wasn't significant before, is now significant at 0.05 level, right? So once you have this, you have much more confidence in using just length and height, okay? Now, when do you stop? Like, should we also throw out the length because height is so significant? And that's a harder question. So there's a thick book that's just for multiple linear regression, how to use it, when to use it, what to do when there's collinearity, and it's a very, very tough topic. So we can't really talk about it here. But let me show you what if we just choose one variable. If we just use the height, so let's see, data analysis, regression, okay. So we use the same thing, but except that we just use column D, the height only. Oops, I made a mistake. What is this? No, cancel. Let me do this again. Regression. Yeah. So. Oh, I see. Okay, I should just do it this way. Okay. So that's what we have. And if I run it, now we just used height, and it even increases significance. Now, if you compare, you see that the adjusted arc shrunk by a little bit. So the amount of explanatory power became smaller, okay? So that there's a trade-off. So maybe if you just use the height, it won't be as exact as using both length and height, but your p-values are smaller, so you don't know what it means, okay? So that's something that has to be discussed outside this classroom, but it's good to know that such problems exist.